Welcome to this explainer. Let's just dive right in, shall we? You know, it's a funny thing. Software bugs absolutely love to hide at the edges. Developers usually nail the middle values, but man, things just break down at the boundaries. To aaj hum STQA, यानी software testing and quality assurance का एक बहुत ही crucial topic cover करने वाला है. Boundary value analysis and robustness testing. हम इसको बिल्कुल scratch से समझेंगे, whizzing the actual handwritten notes you see here. It's going to be super practical.
Here is a quick look at our agenda for today. We'll start with the problem statement, move into boundary value checking, or BVC, solve the 13 cases, tackle robustness testing, compare the two, and wrap up with a solid exam strategy.
All right, let's jump into Section 1, the problem statement, finding the minimum.
Okay, let's set up the exact numerical problem we're going to solve today. इसको step by step समझते हैं. If you look at the problem statement written at the top, it says, we need to write test cases to find the minimum of 3 numbers, A, B, and C, where the valid inputs are strictly between 1 and 50. So हमारे पास exactly 3 input variables हैं, right? A, B, and C. इसका मतलब mathematically our n is equal to 3, and our valid range is 1 to 50. The software just needs to look at these 3 numbers and spit out the smallest one. Sounds simple enough, right? Moving on to Section 2, Boundary Value Checking, or BVC for short.
Now, think about it. Instead of just randomly throwing numbers at this software, like, 17, 25, or 34, we need a proper systematic approach. यहीं पर boundary value checking picture में आता है. If we look closely at this number line diagram in the notes, यहाँ हमारी valid input range 1 से 50 है. The absolute minimum is 1 and the maximum is 50. In BVC, we select exactly 5 specific boundary values for each input variable. We take the minimum, which is 1, minimum plus 1, so 2. The maximum, 50. Maximum minus 1, which gives us 49. And finally, norm, or nominal, which we've set to 25. Now, what's really crucial to understand here is that the nominal value, 25, is just a representative, safe, normal value right in the middle of our range. It is actually not a boundary itself.
So, total test cases कितने होंगे? Honestly, you don't have to blindly memorize the stuff. Look at the calculation written right there. The universal formula for VVC cases is simply 4n plus 1. Since our n is 3 because of our 3 variables, A, B, and C, we just calculate 4 times 3, which is 12, plus 1. And boom, that gives us exactly 13 test cases. This simple math guarantees that we've covered all the really crucial valid boundary combinations.
Let's move to Section 3, actually solving these 13 BVC cases.
Okay, so the most important thing here is understanding the underlying pattern to generate these 13 cases. Rote memorization is just not going to work. Let's analyze this handwritten BVC table. यहाँ हमारा mental model एकदम clear and simple होना चाहिए. एक variable को boundary par ले जाओ, बाकी variables को उनकी controlled value par रखो, or expected output checked for. Let's look at test case 1. A, B, and C are all at minimum, so 1, 1, 1. The expected minimum output is naturally 1. Now check out test case 2. We keep A and B at min, which is 1, but we push C to min plus 1, making it 2. The output is still 1, right? Because 1 is still the minimum. We systematically shift this logic. By case 4, we test A at min plus 1, which is 2, while B and C stay at 1. Then we do the exact same dance up at the upper boundary. Look at test case 5. Everything is at max, so 50, 50, 50. Cases 6, 7, and 8 systematically test max minus 1, which is 49, against those max values. See, it's a beautifully logical pattern.
In this next part, brilliantly shows how we finish off the 13 cases by testing our nominal value, which is 25. In test case 9, all inputs are set to nominal, so 25, 25, 25. After that, cases 10 through 13 test the extreme boundaries, so min and max, against those nominal values. For instance, look at test case 10. A is at min, which is 1, while B and C are nominal at 25. The expected minimum output here is obviously 1. The genius of logically isolating one variable at a time like this is that if the software crashes on, say, test case 12, the developers know exactly that the logic completely fails when variable C is at min and the others are just normal. It pinpoints the exact edge case.
But wait a second. BVC ने सारे valid boundary values तो check कर लिए हैं. लेकिन क्या होगा अगर कोई user valid range के बिल्कुल बाहर की value enter कर दे? Like, what if someone types in a 0 or maybe 55? BVC actually completely misses this real-world scenario.
Which brings us perfectly to Section 4, Robustness Testing.
This is exactly why we need this next step.
Robustness testing is where we ensure our software doesn't just work well under good conditions, but actually survives the bad ones too. Focus on the red handwritten text here. In robustness testing, we also check for invalid boundary values. We're literally adding 2 extra values to our arsenal, min -1, which gives us 0, and max +1, which gives us 51. Because our allowed valid range is strictly 1 to 50, both 0 and 51 are totally invalid. The software shouldn't even try to process these, it needs to gracefully reject them.
Because we've added these 2 brand new invalid boundaries, our formula expands. It now becomes 6n plus 1. Looking at the calculation for our problem where n equals 3, we simply do 6 times 3, giving us 18, plus 1. So that gives us a total of 19 test cases for robustness. Now let's quickly walk through this handwritten 19-row robustness table. Do you notice the red crosses? Those highlight the completely invalid cases. Whenever 0, which is -1, or 51, which is max +1, is introduced into the inputs for A, B, or C, the expected output isn't a number anymore. It absolutely must be invalid input. For instance, test case 1, A, B, and C are all 0. Output, invalid input. Test case 5, all are 51. Output, invalid input. But check out cases 15 to 19 at the bottom. These are our baseline valid cases, all min, all max, all nominal, and some mixed valid values. Robustness includes these, just to make sure the core valid logic hasn't suddenly broken while the software is busy trying to handle the invalid stuff.
Next up is Section 5, understanding the exact difference between BVC and robustness.
You know, at this point, students often get a bit confused between the two during exams. Let's make the difference crystal clear. Here's a super simple analogy. Think of your valid range as a gated compound. BVC is basically checking the inside edges of the gate, making sure the hinges and locks work perfectly from the inside. Robustness testing? Well, that's checking those inside edges, plus testing what happens when completely invalid inputs try to smash into the gate from the outside.
This little summary table in the notes perfectly captures the difference. BVC uses only valid boundaries, min, min plus 1, nom, max minus 1, and max. Its formula is 4n plus 1, yielding 13 cases. Robustness uses all of those, plus the invalid boundaries, min 1 and max plus 1. Its formula is 6n plus 1, yielding 19 cases. Honestly, it's simple, clear, and really easy to remember.
Finally, Section 6, our universal exam strategy and revision.
All right, we've covered the core concepts. Now let's talk about actual execution. How do you tackle a brand new numerical in your exam without completely panicking? Just follow this universal algorithm. Step 1, identify n, which is the number of input variables. Step 2, write down your minimum and maximum valid values, and immediately calculate min plus 1 and max minus 1. Step 3, pick a suitable nominal value sitting safely in the middle. Step 4, write down your formula, whether that's 4n plus 1 or 6n plus 1. And Step 5, generate your test cases systematically. Just remember the golden rule. Change one relevant input variable to a boundary while keeping the others controlled. Please don't learn this. Just let the logic guide you.
If this is a 5 or 10 mark question, presentation is literally everything. Structure your answer clearly, just like you see here. State the problem, clearly list your variables and boundary values, show the actual formula calculation, and then draw a properly labeled table. Your columns absolutely must be test case number, variable A, B, C, expected output, and a short explanation column. Do this, and it makes it practically impossible for the examiner to deduct marks.
Okay, time for a really quick rapid-fire revision. What is the formula for boundary value checking? Yep, it's 4n plus 1. For n equal to 3, how many cases? 13 cases. And what does robustness add to the mix? It adds the invalid boundaries, min minus 1 and max plus 1. What is the robustness formula? It's 6n plus 1. For n equal to 3, how many cases? Exactly, 19 cases. Just remember, BVC valid boundaries check करता है and robustness valid के साथ invalid boundaries भी check करता है.
Which brings us to our final thought for this explainer, perfectly captured in this conclusion cloud in the notes. Test the edges to secure the stability. Look, you don't just remember VVA now, आपको इसका core logic literally समझ आ गया है. You can actually generate these tables yourself without looking at any textbook or guide. So next time you are building or testing any piece of software, ask yourself, have you really pushed it to the edge? Thanks so much for joining me today, and happy testing.